Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. In this session, we will discuss about the topic on volume integral. It is related to vector calculus. Okay, it is related to vector calculus. Already in the previous sessions, we discussed line integral, surface integral, and now we will discuss about the topic on volume integral. Okay, what is the difference between line integral, surface integral, and volume integral means line integral is single integral form. Okay, surface integral means double integral form. Volume integral means it is in triple integral form. That's the difference between these three. Okay, once again, line integral, here the topics are generally already we discussed in the previous classes. Line integral means single integral. Either integrate either with respect to x or y or z. Surface integral is double integral form. Surface integral is double integral form. That means integrate with respect to either xy or yz or zx. But what is volume integral? Volume integral means it is in triple integral form. Okay, it is in triple integral form. We have to integrate with respect to dx, dy, dz. That's the difference between line, surface, and volume integral. Now let us start with the concept of volume integral. Okay, what is volume integral here? Let V be the volume bounded by a surface. R bar is equal to F bar of U comma V. Let F bar be a vector point function defined over V. Okay, here what is volume? V be the volume bounded by the surface. What is the surface here? R bar is equal to F bar of U comma V form. Let F bar of R means what here? Vector point function. Vector point function defined over V. Okay, here divide V into M sub-regions of volumes delta V1, delta V2 and so on up to delta Vm. Here we have to divide V into sub-regions of the volumes. For that volume sub-regions are delta V1, delta V2 and so on up to delta Vm. Let PIR of I be a point in delta Vi. Okay, in that sub-regions we have to take one point. What is that point here? Pi of Ri. Then from the sum of Im is equal to, what is the form of that? In sigma equal to 1 to m F bar of Ri into delta Vi. Okay, let m tends to infinity in such a way that delta Vi shrinks to a point. That delta Vi shrinks to a point, the limit of Im, if it exists, it is called volume integral of F bar of R. In the region, V is denoted by integral V F bar of R or integral V F bar of dV. This is the general definition, but the concept is here. Volume integral is triple integral form, that the function is F bar, and what is dV here? What is dV? F bar of dx, dy, dz. This is simply, I'll write triple integral of F bar of dx, dy, dz. That's the concept of the volume integral, triple integral of F bar of dx, dy, dz. Now let us start with the first question. That is, this is the basic definition of the volume integral, that is triple integral of F bar of dx, dy, dz, and that Cartesian form is here. Let F bar of R is equal to, what is F bar? One vector point function here. What is the vector point function here? That is the form of F1i bar plus F2j bar plus F3k bar, where F1, F2, F3 are functions of x, y, z. Okay, we know that here what is dv? dv is equal to dx dy dz. Okay, therefore the volume integral is given by integral v f bar dv is equal to. Okay, here I'll write clearly what is f bar. Okay, that is f1 I bar plus f2 j bar plus f3 k bar. Okay, triple integral of f1 I bar plus this is f2 j bar plus f3 k bar into dx dy dz. Simply I'll write that as I bar into integral of triple integral of f1 into dx dy dz plus j bar into triple integral of f2 dx dy dz plus k bar into triple integral of f3 dx dy dz. Already we know that from the previous slide, volume integral means f bar dv. What is the form of that? From the Cartesian form, I'll write each and every term here. What is f bar here? That is vector point function which is in the form of f1 I bar plus f2 j bar plus f3 k bar. And what is dv here? dv means dx dy dz. dx dy dz. From that formula, I bar into triple integral of f1 dx dy dz plus j bar into triple integral of f2 dx dy dz plus k bar into triple integral of f3 dx dy dz. This is the Cartesian form for the volume integral. Okay, next. Now, I'll start with the first question here. What is the first question on the volume integral? If f bar is equal to, okay, what is the function form? F bar means always one vector point function. Here the vector point function form is 2xz I bar minus xj bar plus y square into k bar. Evaluate integral v f bar dv, where V is the region. What is the V here? It is the region bounded by the surfaces. What are the surfaces here? X is equal to 0, X is equal to 2 and Y is 0 and Y is equal to 6 and Z is equal to X square and Z is equal to 4. Here V is bounded by the surfaces X is 0 to 2 and Y is 0 to 6 and Z is equal to X square to 4. Okay, that means what are these? These are the limit points of the X, Y and Z. Okay, now we can calculate triple integral form. That means volume integral as integral V f bar dv. Okay, then the solution is here. What is f bar? Given question, that is vector point function is 2xz I bar minus xj bar plus y square k bar. Okay, 2xz I bar minus xj bar plus y square k bar. The volume integral formula is integral v f bar of dv. Okay, now I am substituting each and every term in the given formula. That is f bar is the given function, that is 2xz I bar minus xj bar plus y square k bar into dx dy dz. That is, here I will take each and every term separately. Okay, that means I bar into. Okay, here what are the limits for x, y, z? Here x limits are 0 to 2 and the y limits are 0 to 6 and the z limits are x square to 4. And here from the given vector point function, what is I bar coefficient? 2xz into dx dy dz minus j bar into triple integral of, okay, x limits are 0 to 2 integration of and y limits are y is 0 to 6, that integration of, and integration of z limits are here x square to 4 and here j bar coefficient is x into dx dy dz plus k bar into x limits integration of triple integral of, that the first integration limits are 0 to 2, integration of y limits are 0 to 6, integration of z limits are x square to 4. Okay, here the k bar coefficient is what? Y square into dx dy dz, y square into dx dy dz. Now first I'll integrate with respect to z. Why? Because once you see here, okay, z limits are in terms of x. Z limits of in terms of x, that means first I'll integrate, okay, for the triple integral form means dx dy dz means main concept is first integrate with respect to z, after that integrate with respect to y, and after that integrate with respect to x. That's the concept of the triple integral. And next concept is here depending on the limit values, okay, either z is in y means first integrate with respect to z, and the remaining two limits are in x and y means depending on that we can integrate either x or y. But the main concept of the volume integral means, okay, that is triple integral means first integration with respect to z, and after that integration with respect to y, and after the integration with respect to x. That's the concept of the volume integral. That's why first I'll integrate with respect to z. How to integrate here with respect to z? What are the z integration with respect to z means? That is z square by 2. Okay, here the integration of z is z square by 2. Okay, that means I'll write here, that is I bar into x is 0 to 2 and y limits are 0 to 6, and next integration with respect to z means with respect to z as 2x as constant, and z integration is z square by 2. Okay, and what are the limits for that? X square to 4 and integration dx dy. That's the first part here. Okay, from that here 2 to cancel, we got here xz square form. Xz square limit points are x square to 4 dx dy. That's the first part. And the second part here j bar into integral of x is 0 to 2 and y limits integral of y is 0 to 6. Here also same, first integrate with respect to z. But here what is the function? X as the function. With respect to z integration means x as the constant. Then here one integration as z. That means here x as it is and one integration as z. That limit points are here x square to 4. That's the second part. That is the j bar coefficient integration with respect to z. Plus what about the k bar here? K bar coefficient is here y square. But here we have to integrate y square with respect to z. That means here y square as the constant. Y square as the constant with respect to z. That means here 1 is there. 1 integration is how much? That is z. That means plus k bar into integral of x is 0 to 2 and integral of y is 0 to 6 y square into, okay, that one integration is z, that limit points are x square to 4 dx dy. That is this step. Okay, after the integration with respect to z, this is I bar integration of x square to 2, 0 to 2, integral of y is 0 to 6, xz square, x square 4 dx dy, minus j bar into integral x is 0 to 2, y is 0 to 6, xz square, limit points are x square to 4 dx dy, plus k bar into integral of x is 0 to 2, integral of y is 0 to 6, y square, z limit points are x square to 4 dx dy. After the integration with respect to z, now substitute the limit points of the z. That limit points are here. What about the first limit point? Upper limit point as 4 and the lower limit point as x square. Okay, that is, I'll write clearly here after substituting the limit points of z here. I bar into integral of x is equal to 0 to 2 and y is 0 to 6. X is as it is. Here the next is z square. Z square upper point is 4. That means 4 square is how much? 16. Minus lower point is x square. That means z square, in place of z you can substitute the lower point as x square. That x square as x power 4 into dx dy. Okay, that is x into 16 minus x power 4 into dx dy minus j bar into integration of x is 0 to 2 and integration of y is equal to 0 to 6. Here the function as x and z as z limit points here, upper point as 4 and the lower point as x square. That is x into 4 minus x square dx dy minus k bar into k bar into integral of x is 0 to 2 and integration of y is equal to 0 to 6 here. Y is equal to 0 to 6 and here the function is y square into z upper point as 4 and the lower point as x square. Okay, that means 4 minus x square into dx dy. Okay, 4 minus x square into dx dy. That means here plus 4 minus this is x. Okay, this is 4 minus x square. And the next step, or else take here minus of k bar into y square minus x square minus 4 also correct, but generally we have to substitute the limit points here. First is upper point, after that lower point, but here the procedure here we can take a lower point minus of 4, but here we can take minus ma, that's why this is also correct. Okay, that means 4 minus, here I'll write the last step, k bar into x is 0 to 2, y is equal to 0 to 6, y square into 4 minus x square into dx dy is also correct, or minus of k bar into x is equal to 0 to 2, y is equal to 0 to 6, y square of x square minus 4 into dx dy is also correct. Once you see here, I'll take here minus outside, minus into minus plus k bar into x is equal to 0 to 2, y is equal to 0 to 6, 4 minus x square into y square dx dy. Generally, after substituting the limit points, we get like this. But here the procedure is sometimes they are writing here minus is taking common and the remaining they are considering y square of x square minus 4 into dx dy. This is also correct or this is also correct. Okay. Then next. Now, after substituting the limits of z, now integrate with respect to y. Okay, what's the concept of the volume integral? First integrate with respect to z, after that integration with respect to y. Now, z integration is over and that limit points also substituted. Now, integrate with respect to y. Okay, that means here I bar into integral of x is equal to 0 to 2 with respect to y integration here 16x minus x power 5. Okay, that means here I'm multiplying x is inside the brackets, that is 16x minus x power 5 with respect to the y integration here. This is the constant. That means here 1, that integration with respect to y as y. Okay, therefore what are the limits for y here? 0 to 6. What are the limits for y here? 0 to 6. Minus, okay, here minus j bar into here minus j bar into integral of x is equal to 0 to 2. Here also I'll multiply x inside the brackets, that is 4 into x 4x minus x cube. With respect to the y integration, this is the constant, that 1 integration with respect to y as y, that limit points are 0 to 6 dx minus k bar into integration of x is equal to 0 to 2. I'll take x square minus 4 as constant and y square integration. Whatever the y square integration is, this is y cube by 3. Y square integration is y cube by 3. And what are the limits for that? 0 to 6 into dx. Now substitute the limit points of y after the integration with respect to y, that as I bar into, okay, I bar into, first I'll write this step here, after this I bar into integral x is 0 to 2, 16x minus x power 5 into y limit points, upper point as 6 and lower point as 0 into dx minus j bar into x is equal to 0 to 2 4x minus x cube, upper point as 6 and lower point as 0 minus k bar into integral of x is equal to 0 to 2 x square minus 4. Okay, that is limit point, substitute the limit points of y, that is 6 cube by 3 minus 0 into dx. There also into dx. Okay, after this step, this is equal to I bar into, okay, x is equal to 0 to 2, 16x minus x power 5 into 6 dx minus j bar into integral of x is equal to 0 to 2, 6 into 4x minus x cube minus k bar into, okay, integral of x is equal to 0 to 2, okay, 6 cube, that is 211 by 3 into x square minus 4 into dx. Okay, after substituting the limit points of y, it will be converted I bar into integral x is equal to 0 to 2 16x minus x power 5 into 6 dx minus j bar into x is equal to 0 to 2 6 4x minus x cube minus k bar into integration of x is equal to 0 to 2 211 by 3 into x square minus 4x dx. After this, now integrate with respect to x. After substituting the y limits, after the simplification, now integrate with respect to x. That is, what about the integration for that? After this step, that is I bar into, okay, 16x, x integration as x square by 2 minus x power 6 by 6 into 6. And whatever the limit points for x here, x is 0 to 2 minus j bar into 6 into 4 x integration as x square by 2 minus x cube integration as x power 4 by 4. Limit points are 0 to 2 minus k bar into 211 by 3 and x square minus 4. That integration is here x cube by 3 minus x cube by 3 minus 4x. And the limit points here 0 to 2. Okay. Here the limit points x square as x cube by 3 minus 4x. Here minus x cube by 3 plus x cube by 3 minus 4x. Okay. Now after this is the step. After this here 8x square, here 2 8s are, and here 2 2s are, and the next here the limit points are I bar into 8x square minus x power 6 by 6. Limit points are 0 to 2 into 6 minus j bar into 2x square minus x power 4 by 4. Limit points are 0 to 2 into 6 minus k bar into, okay, minus 4x plus x cube by 3 integral 0 to 2 211 by 3. If you are taken minus 4x plus x cube, here minus 4x plus x cube by 3 into 211 by 3. Now integrate. After the integration with respect to x, now substitute the limit points of x. What are the limit points for that? 0 to 2. Substitute the upper point as 2 in this function, and here substitute the lower point, and j bar coefficient, in the j bar coefficient also substitute x upper point after the lower point, and k bar coefficient is here minus 4x plus x cube by 3. Substitute the limit points here 220 into 211 by 3. After the simplification, I'll write here that step. That is I bar into 8 into 2 square minus 2 power 6 by 6 into 6 minus j bar into, okay, if you are substituting the lower point, that is completely 0, then 2 into here j bar coefficient 2x square minus x power 4 by 4. For that, I am substituting the upper point as 2. That is 2x square, but in place of x, I am substituting 2 minus 2 power 4 by 4. After substituting the lower point, that is completely 0, minus k bar into minus 4 into here upper point as 2 plus x cube means 2 cube by 3. If you are substituting the lower point, that is 0 into 211 by 3. After substituting the limit points like this, that is I bar into 8 into 2 square minus 2 power 6 by 6 into 6 minus j bar into 2 into 2 square minus 2 power 4 by 6 into 6 minus k bar into minus 4 into 2 plus 2 cube by 3 into 211 by 3. After the simplification here, we got I bar coefficient as 128 into I bar and j bar coefficient as 24 and the k bar coefficient as minus 384. Okay, this is the answer for the first question. Okay, therefore, triple integral of v f bar dv for the given vector function, volume integral value is 128 into I bar minus 24 into j bar minus 384 into k bar. That's the concept of the volume integral. Volume integral means what? It is in triple integral form. In the triple integral form, first integrate with respect to z, after that integrate with respect to y, and after that integrate with respect to x. For that, we got the vector point function. Here the answer is also in the vector, that is 128 into I bar minus 24 into j bar minus 384 into k bar. This is the answer for the first question. Okay, next I'll go through the second question here. If f bar is equal to 2x square minus 3z into I bar minus 2xy into j bar minus 4x into k bar. Then evaluate here two questions. What are the form of the first question? Integral v del dot f bar dv. Second question, integral v del cross f bar dv, where v is the closed region bounded by, what are the limits here? X is equal to 0, y is equal to 0, z is equal to 0, and the surface is here 2x plus 2y plus z is equal to 4. Okay, 2x plus 2y plus z is equal to 4. Okay, first I'll start with the first question. What about the first question form here? Integral v del dot f bar dv. Okay, which is in the form of del dot f bar, means that is in the product of del into f bar. From the given question, what is f bar? F bar is equal to 2x square minus 3z into I bar minus 2xy into j bar minus 4x into k bar. What is del? Del means I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. That is also in the vector form. Okay, and what about dv here? Dx, dy, dz. Here we have to calculate the volume integral for del dot of f bar. That's the first question. And the second question is integral v del cross of f bar dv. Del cross of f bar dv means what? That is the curl f bar. Curl f bar means that is the cross product of del into f bar. Okay, here we have to calculate the volume integral for the del cross f bar into dv. dv means dx, dy, dz. But here what are the limit points for dx, dy, dz? If you are integrating with respect to x, y and z, means first we can take the limit points from the given surfaces. What are that? Here x is equal to 0, y is equal to 0, z is equal to 0 and 2x plus 2y plus 2z is equal to 4. Okay, from that first I'll take solution for this. First, from the given surfaces here, given points, x is 0, given x is 0, y is equal to 0 and z is equal to 0. And the surface is here 2x plus 2y plus z is equal to 4. From that I am taking the z limit point, that is z is equal to 4 minus 2x minus 2y. Therefore, what are the z limit points here? Z limit points are z is equal to 0 to 2, z is equal to 4 minus 2x minus 2y. Let us take this as the first equation. From that first equation, we got the z limit points are z is equal to 0 to 2, z is equal to 4 minus 2x minus 2y. After we got the z limit points, if you are substituting z is equal to 0 in this first equation, substitute z is equal to 0 in the first equation. From that we got, okay, 2x plus 2y is equal to 4. From that 2y is equal to 4 minus 2x. From that y is equal to what? 2 minus x. Therefore, if you are substituting z is equal to 0, we got y limit point as 2 minus x. And what about the initial point for that y? Y is equal to 0. Therefore, what are the y limits here? Y limit points, y is equal to 0 to 2 minus x. Y is equal to 0 to 2 minus x. Next, I am substituting y and z as 0. Substitute y is 0 and z is equal to 0 in the first equation. From that we got x point. Okay, from that we got x point. From that is 2x plus 2 into 0 plus z as 0 is equal to 4. From that 2x is equal to 4. X is equal to how much? 2. Therefore, here x initial point already given in the question, that as 0. Therefore, the x limit points are x limits 0 to 2. X limits 0 to 2 and y limits z is equal to 0 to 4 minus 2x minus 2y, and y limits are 0 to 2 minus x. This is the concept for finding the limit point from the given surface. Okay, next. Now I'll take the first question. From the first question, first I'll calculate del dot f bar. Okay, from the first question I'll calculate del dot f bar. What is del here? What is del? I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. Dot, what is f bar here? 2x square minus 3z into I bar minus 2xy into j bar, 2xy into j bar plus minus 4x into k bar. This is the given vector point function, which is in the form of 2x square minus 3z into I bar minus 2xy into j bar, and minus 4x into k bar. Once you see here del operator and f bar operator, these two are in the vector form. Okay, then how to multiply both the vectors here? I bar coefficient as here dou by dou x of 2x square minus 3z minus here j bar coefficient as dou by dou y of minus 2xy in plus here what about the k bar coefficient for the del operator, that is plus dou by dou z of here k bar coefficient for the second vector, that is minus 4x. From that, with respect to x differentiation as 4x, with respect to x z as 0, minus into minus plus, with respect to x y in differentiation as 2x. Okay, that is differentiation as 2x, and with respect to z as 0. That as 0. Therefore, here, once you see here plus. Therefore, this is minus. Therefore, del dot f bar. What about del dot f bar here? 4x minus 2x as 2. Okay, for the first question here, del dot f bar is equal to how much? 2x. Therefore, from the first question, now we know that del dot f bar and the limit points of x, y, z. Therefore, integral v del dot f bar dv, that is equal to triple integral of x limit points are 0 to 2 and y limit points are 0 to 2 minus x, and what are the z limit points here? z limit points are 4 minus 2x minus 2y into 4 minus 2x minus 2y. Okay, and the function is here. What about del dot f? Del dot f bar as 2x. Now substitute here 2x into, what about dv here? Dx, dy, dz. Dx, dy, dz. Okay, now integrate first with respect to z. What are the concept of the volume integral? First integration with respect to z. For that, integral of x is equal to 0 to 2 and y limits are integration of y is 0 to 2 minus x. With respect to z integration, 2x as a constant. That means 2x into here 1, that one integration as z. One integration as z, that the limit points are here 0 to 4 minus 2x minus 2y into dx dy. 4 minus 2x minus 2y. Okay, after the integration with respect to z, now substitute the limit points. Okay, from substitute the limit points, that's the second third step. That is, here x is equal to 0 to 2, y is 0 to 2 minus x, 2x into, here what is z upper point? That is 4 minus 2x minus 4 minus 2x minus 2y. And if you are substituting the lower point, that is 0 into integration with respect to x and y, that is dx dy. Okay, now integral of x is equal to 0 to 2, x is equal to 0 to 2 and y as 0 to 2 minus x, y as 0 to 2 minus x. I'm multiplying inside the brackets with 2x, that is 8x, 2x into 4, 8x, minus 2x into 2x, 4x square, minus 2x into 2y, that is 4xy into dx dy, into dx dy. From that, after this, I'm integrating with respect to y. Okay, after substituting the z limit points, now I'm integrating with respect to y, that as integral of x is equal to 0 to 2 and 8 into x with respect to y integration as y minus 4x square into y minus 4x into y integration as y square by 2, y square by 2, and the limit points for that 0 to 2 minus x dx, 0 to 2 minus x dx. From that x is equal to 0 to 2. I'm substituting the limit points for that y, that is 8x into 2 minus x minus 4x square into y upper point as 2 minus x minus 4x into y upper point as 2 minus x whole square by 2. We are substituting the lower point, that is completely 0 into dx. Into dx, here 2 2s are. Okay. Now I'm simplifying this. X is equal to 0 to 2, 16x minus 8x square minus 4 into 4x square into 2x, that is 8x square, minus into minus plus 4x cube minus 2x into, what is the expansion of 2 minus x whole square? That is 4 plus x square minus 2x into dx. Into dx. After this, x is equal to 0 to 2, 16x minus 8x square minus 8x square, that is 16x square plus 4 into x cube plus 4 into x cube minus 2x into 4, that is 8x minus 2x cube minus 2x into minus 2x, that is plus 4x square. Okay, minus 2x into minus 2x, once again minus 2x into 4 as minus 8x, minus 2x into plus x square, minus 2x cube, minus 2x into minus 2x, that is plus 4x square into dx. Next step, okay, once you see after substituting the y limit points, here the equation completely, that function will be converted in terms of x, okay. Now here, whatever the x cube terms, 4x cube minus 2x, after the integration with respect to y and substitute the limit points of x, and the next steps are here, integral x is equal to 0 to 2. Here, what about the x cube terms here? 4x cube minus 2x cube. That is 2x cube. And next, minus 16x square plus 4x square. That is minus 12x square. And the next step, and the next one, 16x minus 8x. 16x minus 8x as plus 8x into dx. Okay, right. Now integrate with respect to x. Integration with respect to z over and y over. Next integrate with respect to x. That is 2 into x cube integration as x power 4 by 4 minus 12 into x square integration as x cube by 3 plus 8 into x integration as x square by 2. And the limit points for that 0 to 2. Therefore, now substitute the limit points here. Here 2 2s are, and next 2 4s are. Then x power 4 by 2 minus here 3 4s minus 4 into x cube plus 4 into x square. Okay, limit points here 0 to 2. X power 4 by 2 minus 4x cube plus 4x square. Limit points are 0 to 2. Now substitute the limit points. Upper limit point for the x as 2 power 4 by 2 minus 4 into 2 cube plus 4 into 2 square minus of, after substituting the lower point, that is 0. Here 1 2 cancel, that is 2 cube minus 4 into 8 plus 4 into 4. Okay, from that 8 minus 4 8s are 32 plus 16. Okay, 32 plus 16. From that 16 plus 8 minus 32 as minus 8. After the simplification here, 8 minus 32 plus 16 as minus 8. This is the final answer for the first problem, that is integral of v del dot f bar dv. Okay. Okay. And the next problem here, whatever the next problem, integral v del cross f bar dv. Okay, next class we will discuss that question. Okay, but this is the procedure for the volume integral. That is, what is the concept of the volume integral? Okay, first we can integration with respect to z, after that integrate with respect to y, and after the integration with respect to x. Okay, for that second question, first part, integral v del dot f bar dv, how much you got? That as minus 8. Next session we will discuss integral v del dot f bar dv. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.